So, we've gone through various forms of work. Let's really dig deep now into different mechanical forms of work. Now, for us to have a mechanical type of work, there's two things we need. One is a force, and it has to be acting on a boundary. You're like, well, what does that mean by boundary? Well, for us, we often deal with pistons, okay? So just don't forget that. So I really don't care about forces acting over here or here or here or here, because none of those are really doing anything because I've got a rigid exterior of this piston. It doesn't bend. However, right here, the piston head can move up and it can move down. And so forces that are applied there do matter. Okay, so I need a force acting on a boundary that can actually move. And the second thing is the boundary has to move. Now, the way you probably saw this in your physics class is I have a force. That force pushes a box some sort of distance, and I can figure out how much work I've done for that. So, work equals force times distance. They use S here. That's fairly common for path, because your path doesn't have to be a straight line. It can be all curvy. And I can also figure out how it would happen if the force was not constant, which we don't have happen too much. You might get it in this chapter, but in future chapters, we typically just give you work. Whoop, went too far. My bad. Now, why do I bring this up? Why do we even care about this? Because you're saying this is thermodynamics. We don't have boxes that we're moving around. There's no calorics that are those magical heat particles. What we do have is piston heads. And so this is where this comes into play. Because for me, if I'm trying to figure out how much work a particular gas is doing, like if I put heat into this system, and well, that's going to cause this guy to move. Why does it cause that guy to move? Because the pressure in here is going to increase. When the pressure increases, let's look it out here. So I'm going to have a circular piston head, and we know that pressure is equal to force over area, right? So if I know the area of this piston head, well, that means I can figure out the force. So it's going to force to be equal to pressure times area. Okay, now I've got a force. Okay, so I've got this force right here. And that's going to cause that piston head to move. How far will it move? Well, it'll probably move a distance s. And that means that the work that your gas just did in moving that piston head is going to be force times s. Wait a minute. Oh my goodness, we're back to the exact same equation. So while we will be typically talking about things in terms of pressure and volume, it's all coming back to that same simple thing. We're moving a boundary by applying a force. Where does the force come from? Pressure in this case. But we're still just moving that boundary. Okay, let's talk about some other kinds of work. Shaft work. So for shaft work, we have something that is spinning. Shafts are the most common way we actually have of transferring power. Think about it. Your car, a whole bunch of things spinning there, and if you look in the engine, you'll see that it is spinning a shaft. That's what sends power from the engine to your wheels and also to everything else. It's how you get electricity in your car. Everything else is because something is spinning. A shaft is spinning, gears are connecting those together. All that's happening. Now, if I have a shaft that's spinning, then there is something that is trying to spin it. So the way we think about that usually is you might have heard the word torque. Torque, the best way to say it, I can think about it is it's like the twistiness, okay? That's a very technical term, I know. But it's how much are you trying to twist it? If you're applying a lot of torque, you're really trying to twist something. Little torque, not so much. It's got a nice technical definition, though. It's simply a force times a distance from the center of your shaft. So you can see that distance right here. Another thing it doesn't show right here in the picture is that those two have to be perpendicular to each other. If the force isn't, then only the perpendicular component matters. So if I had a situation like this, here's my distance, here is my force going off at an angle, I would only care about this component right here, the perpendicular component, not this component right here. That one wouldn't do anything. Okay, so we've been talking about how work is force times distance, right? Work is force times distance. Well, what distance is this thing moving? In this case, it's simply how far did you go travel in this circle? So we have a particular number of revolutions. That's the circumference right there. That's the circumference of the circle. And I say, well, how many times did I go around the circle? So I can plug that in. If I went around 5 times, N would be 5. If I went around 10 times, N would be 10. And so from that, I can get the work of a shaft is equal to 2 pi N times T. So this is saying how many times did you go around the circle times, 2 pi is for you went around the whole circle. N is saying how many times did you do that, and T is the torque. When where R went, it got canceled out because we went back from our force. And the last thing here is we can simply say, well, if we want to have the work over time, or the power, which is much more common, then we need to know how many revolutions per second we have. Now, usually you'll have rotations per minute, RPM. You'll have to convert those to revolutions per second, which is not too hard. Okay, now I've talked about your car, but another place we see this, a really big place we see this, is boats. Because they've got some gigantic engine which is spinning a propeller, which is the most direct form we have of sending power through a shaft. Another cool thing is you can even think about nuclear powered aircraft carriers, and those also still use a shaft to transfer the work. But in that case, we have a whole bunch of different forms of energy. We've got nuclear that goes to thermal, that goes to mechanical, that goes to magnetic, that goes to all these things all the way down the line until it finally gets the propeller. Luckily for us, we don't have to deal with all those. We're typically sticking with mechanical and thermal, but still understanding how energy moves through your system is important. And understanding how to work with different types of energy and different types of work and different types of power is also important. Okay, so we're going to go into an example next time, so tune in soon and we'll go through a problem. Thank you so very much. See you soon.